Welcome to Educator.com. In previous lessons, we discussed several methods for solving systems of equations. Today, we're going to look at how we can apply those different methods to various situations. First, to review, we've covered 5 methods for solving a system of equations. The first method was by graphing. Recall that if you have a system of equations, you can graph the 2 lines described by those equations, and the point at which they intersect is the solution. Although there are some situations where you may get an infinite number of solutions, such as if you have a single line described by both the equations, or if there are parallel lines, there are no solutions to the system of equations. The second method is the addition method. In that method, we added 2 equations so that a variable would cancel out, and then we would use the remaining equation, single equation, with 1 variable to solve for that variable. Again, you could get these 3 possibilities of 1 solution, no solution, or an infinite number of solutions. Subtraction is very similar to addition, except this time you're subtracting. So if you had 2 equations where one of the variables had the same coefficient, such as 2x plus 4y equals 8 and 2x minus 3y equals 9, what I could do is subtract the second equation from the first so that a variable will drop out. What we also saw is that sometimes you need to perform multiplication in order to get the equations in a form where you could add or subtract so that a variable would drop out. You may have to multiply by 1 equation. You may have to do both in order to get coefficients that are the same or opposite so you could add or subtract and have a variable drop out. We also learned the method of substitution. And when you can express one variable in terms of the other easily, then substitution is a good method. The ideal situation for this is when you have a variable with a coefficient of 1. When you have a variable with a coefficient of 1, it's a great setup to use substitution. You can then substitute that expression into the other equation and solve. For example, with substitution, if I had a system of equations such as this, I would notice that I had a variable with a coefficient of 1, and I could solve that by substituting this expression into the second equation. Once I have that, I have 1 equation with 1 unknown, and I can solve for y. Okay, today we're going to do some applications that are going to require us to select which method to use to solve the system of equations. And I've given you some hints for determining which method is the most efficient one to use. Determine the best method of solving the system. So I look at what I've got, and it's 3x minus 2y equals 8, 4x plus 2y equals 10. When I look at this, I notice that negative 2y in the first equation and 2y in the second equation have opposites for coefficients. So when I add those together, the y will drop out. Whenever I can get a variable to drop out, I'm in good shape because I can solve the resulting equation with 1 variable. So the method that I'm going to choose is, as the best method, is addition. Now, could I use another method? Yes. I could use substitution, but it'll be a little more complicated because I'll have to isolate one of the variables before I can substitute back in. I could use graphing. Graphing can be tricky though, because in order to be really exact, it's difficult if the point of intersection does not end up being a whole number. If you end up with a point of intersection such as x is 1/3 and y is 1/4, it's going to be very difficult to determine that point. So here, addition is the best method. And just to show you a few steps of how that would work, 3x minus 2y equals 8. 4x plus 2y equals 10. That gives me 7x, and then I'm going to see that my y's are going to drop out. 8 plus 10 is 18. I'm going to end up with x equals 18/7. I could then solve for y by substituting x into either equation. So 3x minus 2y equals 8. That would be 3 times 18/7 minus 2y equals 8. And then you could solve for y. Now, they didn't ask me to solve it out, and so I'm not going to take it all the way, but what they did ask me to do is to determine the best method to solve this system of equations, and addition is the best method. The second example also asks to determine the best method of solving the system. As I look at my system, I have 2x minus 7y equals 8, 3x plus 4y equals 12. Well, I'm thinking about substitution first, and I look at this, and there's no variable with a coefficient of 1. So substitution is probably not the ideal method. Then I consider addition or subtraction. But there's no variables that have the same coefficient where if I subtracted they'd cancel out, or opposite coefficients. You know, if this was 2x and minus 2x, I could just add, but it doesn't work that way. However, what I do see is that I can use multiplication, and then I can go on to add or subtract. Looking at this, if I multiply the first equation by 3 and the second equation by 2, I'll end up with 6x and 6x, and then I can subtract. So the best method is multiplication. For my first equation, I need to multiply by 3. And that's going to give me 6x minus 21y equals 24. That's my first equation. For my second equation, I'm going to multiply the entire equation by 2, which is 2 times 3x plus 4y equals 12. That gives me 6x plus 8y equals 24. Now that I have these two equations, put them one on top of the other, one above the other. I see that I can use subtraction. When I subtract, what's going to happen is that the variable, the x variable, is going to drop out. And once that variable drops out, then I'm going to have an equation, a single equation with a single unknown, and I can solve for y. Once I've solved for y, I can substitute that value back in to solve for x. Again, I'm not going to solve it out. They didn't ask me to solve it out, but what they did ask me is to determine the best method. And I have verified that this is a good method to use. Multiplication, and then that's going to have to be followed by subtraction. Okay, in this example, you'll see that we have sentences. They don't give you the equation. What that means is that we need to first write the equations. The sum of one number and twice another number is 19. The difference of 4 times the first number and twice the second number is -4. Find the numbers. So I have two equations described by these first two sentences. Since I have two unknown numbers, I'm going to let the two numbers be represented by x and y. My first equation, the sum of one number. Okay, I know I'm adding, so I'm going to put a plus. The sum of one number, so x plus the sum of one number and twice another number. So twice another number would be 2y, is, or equals 19. That's my first equation. X plus 2y equals 19. My second equation is described by this sentence. The difference. Difference tells me I'm going to be subtracting. So the difference of 4 times the first number 4x minus twice the second number, 2y. So I have x plus 2y equals 19, and I have 4x minus 2y is negative 4. So when I look at these, I see that there's actually a couple ways I could go about this. I could use addition because I have opposite coefficients. I have 2y and negative 2y. I could also use substitution because I have an x with a coefficient of 1. And I'm going to go ahead and use substitution here. X plus 2y equals 19. Well, I need to isolate my x, which is going to give me negative 2y plus 19. Once I have this expression, what I'm going to do is substitute it in the second equation for x. So my second equation is 4x minus 2y equals negative 4. This gives me 4 times the expression negative 2y plus 19 minus 2y equals negative 4. And this gives me negative 8y. 4 times 19 is 76 minus 2y equals negative 4. Now I'm going to combine my two terms that are similar, negative 8y and negative 2y, to get negative 10y, plus 76 equals negative 4. Subtracting both sides by 76 to get negative 80, and divide both sides by negative 10 will give me y equals 8. Now that I know that y equals 8, I can go ahead and substitute into either one of these originals, or even easier would be to use this form because it's already has x isolated over here. So I'm going to take that y equals 8 and substitute it in to this equation. So that's going to give me x equals minus 2 times 8 plus 19. X equals negative 16 plus 19. So that gives me x equals 3. So my solutions for, it's asking me to find these two numbers, x equals 3 and y equals 8. And there are various methods I could have used. I decided to use substitution because I saw that x had a coefficient of 1. So that was a good method to use here. In my next example, I again have words that needed to be translated into equations. The sum of 4 times one number and 3 times another number is 43. So that's one equation. The difference of 3 times the first number and 5 times the second number is negative 4. Second equation. Find the numbers. Okay, I'm going to let x and y represent the two numbers. Okay, so x and y are going to be the variables I'm going to use to represent these numbers. Translating the first sentence. The sum of 4 times one number. So the sum I'm adding. And what it's telling me is that I'm going to add 4 times one number, 4x, and 3 times another number, so 3y, is. Is means equals 43. Always double check that you translated correctly. The sum of 4 times one number, 4x, plus 3 times another number, 3y, is equals 43. That worked out. Second sentence, the difference, so subtracting, the difference of 3 times the first number, 3x, and 5 times the second number, 5y, is negative 4. Okay, double checking that. The difference, so subtracting, of 3 times the first number, 3x, and 5 times the second number, 5y, is equals negative 4. Looking at this, I can't just add or subtract, because if I add 4x and 3x, the x will not drop out. If I subtract it, it won't drop out. Same with 3y and 5y. Substitution isn't going to be that easy either, because then I'm going to have to solve for x or y and then substitute it in, and that could be messy. What I need to do is use multiplication. And I'm going to need to multiply the first equation by 3, this is one approach, and the second equation by 4. So I'm going to take this first equation and I'm going to multiply it by 3. And the second equation I'm going to multiply by 4. Okay, let's start with the first equation. So I'm going to take that first equation and I'm going to multiply 3 times 4x plus 3y equals 43. And when I figure that out, I get 12x plus 9y equals 129. So this is my first equation. Second equation, I'm going to multiply by 4. So 4 times 3x minus 5y equals negative 4. That gives me 12x minus 20y equals negative 16. So that is my second equation. When I look at this, I now see that if I subtract one equation from the other, the x's will drop out. So I'm going to rewrite those two equations up here. 12x plus 9y equals 129. And then I have 12x minus 20y equals negative 16. And I'm going to subtract, making sure I have all my signs correct since I'm subtracting. 12x minus 12x is 0. That drops out. Then I have 9y minus negative 20. What that's really saying is 9y plus 20y. So that's 29y. 29y. Then I have 129 minus negative 16, and that's equal to 129 plus 16, or 145. And again, if you find yourself making mistakes with the signs, you can always rewrite this as one equation added to another equation, and then reverse the signs. You could just have negative 12x plus 20y plus 16. So you could just write it out like this to avoid mistakes. Actually equals 16. To avoid mistakes. So then I converted this to a negative, a positive, and a positive. Okay. So right now I'm at the step 29y equals 145. Dividing both sides by 29 equals y equals 5. Now that I have y equals 5, I'm going to substitute this 5 back in, and I'm going to go ahead and use the second equation here. 3x minus 5y equals negative 4, which would be equal to 3x minus 5, substitute 5 in, is going to give me 3x minus 25 equals negative 4. 3x, add 25 to both sides, that's going to give me 3x equals 21. Divide both sides by 3, I get x equals 7. My solution, x equals 7, y equals 5. The first thing I had to do is translate these words into a system of equations. When I did that, I saw that I needed to use multiplication to solve this, multiplying the first equation by 3 and the second by 4. That yielded these two equations, and I used subtraction. Remember that subtracting would be the same as adding a negative 12x, a positive 20y, and a positive 16. That gave me 29y equals 145, or y equals 5. At that point, it was simply a matter of substituting y equals 5 into one of the equations to yield x equals 7. So today we applied the various methods that we've used for solving systems of equations. Thanks for visiting educator.com.